Assalamu alaikum dears. Today we will discuss about atom to structure. Atom to structure. So atom has electronic configuration or electronic structure, and it has two parts. One is nucleus, and it consists of neutron and proton, and another is electron, which is revolves around the nucleus in different orbit. Okay, these are the electron. So on the basis of some atomic structure properties, we will learn how electrons are distributed in different energy level, and how many electrons are distributed in each shell, orbit or orbital. So at first we will learn on quantum number. Quantum number. So we have four quantum number. One is principal quantum number. Principal quantum number. It is denoted by n, small n, and it takes the value 1, 2, 3 to n. If n equals to 1, then it will be K shell. N equals to 2, it will be L shell. N equals to 3, it will be M shell. Then it will be go on after increasing the number of n. Then the second one is azimuthal quantum number. In each shell, it has azimuthal quantum number. Azimuthal quantum number. So for each subshells, it has angular quantum number. Angular quantum number, and it will be two parts. One is magnetic angular quantum number, magnetic angular quantum number, and another is spin angular quantum number. Angular quantum number. Magnetic angular quantum number denotes by M L, and it takes the value minus L0 plus L. And spin angular momentum denotes by ms, and it takes the value plus minus half. The fourth one is spin angular quantum number. Spin angular quantum number, and it takes the value only half. So now we will learn about how many electrons are distributed in different energy state on orbit, or on suborbit, or on orbitals or shells. So let's see from principal quantum number. So we know for orbitals, every orbits takes highest 2n square number of electrons. 2n square number of electrons. If n equals to 1, then K shell has 2 electrons. If n equals to 2, then L shell has 8 electrons. If n equals to 3, then M shell has 18 electrons, and it will be go on. If we apply this condition to n square. So for the K shell, it takes 2 electrons. For L shell, it takes 8 electrons, and for M shell, it takes 18 electrons. Now for azimuthal quantum number, each suborbit takes 2l plus 1 number of electron, but it has two states, so it will be multiplied by 2. So if L equals to 0, then S orbit takes, if we put that 0, then take 2 electron. If L equals to 1, then p orbit takes, if it will be 2, 2 2s are 4, 4 plus 1 5, 5 2s are 10 electron. Sorry, this is 1, 2 1 is 2, plus 1 3, 3 2s are 6. If L equals to 2, then d orbit takes 10 electron. If L equals to 3, then f orbit takes 14 electron. Okay, so these are the electronic configuration on the basis of quantum number. Now we see it is nucleus. It consists of proton and neutron, and electrons are revolving around the nucleus. Okay, so it is revolving, that's why there is current. So current is following in this path, closed path. Okay, so if current is following in this closed path, there is some magnetic moment induced. So here magnetic moment mu equals to I for current of electrons, and A is area of this by this closed path. So I and A means pi r square, where r is the radius of the orbit. Now it is denoted by L, and it takes the value 0, 1, 2, 3, 2, n minus 1. For L equals to 0, then it will be s orbital, n equals to 1, it will be p orbital, n equals to 2, it will be d orbital, and n equals to 3, it will be f orbital. It will be f orbital. So these are the subshell or orbit or orbital.